Welcome back to the drive-through, B's and G's. I'd like to congratulate you guys on your 500th page of geometry. Okay, that's big. All right, pulleys. They're so important. And they're connected by a belt. And the radii of the pulleys are 15 and 3. So I got to draw my right angle right there, and this one is 15. And here's my right angle, and that's 3. Okay? The distance between their centers is 24. What kind of problem is this going to be, kiddos? This is going to be a common tangent, a common external tangent problem. This is 24. Find the total length of the belt. Oh, man. All right, let's start by finding the common external tangent, but that's not even going to be all of our issues. So what do? Let's see, we make a rectangle. In this one, I'm going to draw a line that's red that's parallel to the common external tangent. What we have here is a rectangle. So this part is 3. Which makes this little blue part what? 12. And this is our right angle. So we have 12 squared plus x squared equals 24 squared. I don't even know that one. Is that? Oh, is that a 30, 60, 90 triangle? Yes, it is. The x should be 12 radical 3 here. X squared equals the square root of 432. Let's see if that ends up being 12 radical 3. Let's bring out a 9. So that is the square root of 48 times 9. Let's see. Let's bring out. Let's try this divided by 144. Yep. It's 144 times 3. So indeed, that's 12 radical 3, and that's the external tangent. So we know that the external tangent is 12 radical 3 and 12 radical 3. So now our new goal is to find this little part of the conveyor belt or the pulleys and that big part of the pulleys. So let me think for a second. We now know that since this is a 30, 60, 90 triangle, what's this angle right here? I'm going to try to make this bigger. Okay? And we had something like this. So this was our right angle. This was 12. And this was 12 radical 3, which makes this 60 degrees. Can you figure that out? So then what is that, this whole arc? That would be 120 degrees. So this blue conveyor belt piece represents what fraction of circumference? 240 out of 360 degrees. I take that fraction and I multiply by the circumference, which is 30 pi, and I get pi. And you get 20 pi for that one, okay? Now, similarly, if you look at this is going to be 120 degrees. And for the exact same reason, it's just the opposite. So I'm not going to explain that, but let me tell you, this is not an easy problem. So that one, and let's do this in red, will be 120 360ths of the circumference of the little circle, which would be, let's see, 6 pi. So 1/3 of 6 pi is 2 pi. So this is 2 pi, and now I know my answer is 20 pi plus 2 pi, so 22 pi plus 12 radical 3 plus 12 radical 3 plus 24 radical 3. And if you were able to come up with that answer as a decimal, I would still consider you a boss. Boom!